Hello everybody. So we're going to help you get ready for your geometry test by helping you learn how to find the circumference of a circle. Okay? We're going to start off with the definition of the diameter. Okay? And we're also going to need another word. Alright, looks like maybe I wrote piameter, so I'm going to fix that, alright? The diameter. You got me? So, the diameter of a circle is any line that starts on a point, a straight line, that goes through the center of the circle and straight through to another side and stops on another point right there. That's what we call the diameter. The radius is a line that goes from the edge of the circle to the center. So it just stops right there. Okay? Not every combination of radius will be a diameter. So if this is 3, since the definition of a circle is, as most of us know, the length from the center to the edge is always the same. So this is 3 centimeters and this is 3 centimeters, right? Well, this radius and this radius don't necessarily make a diameter. And this radius and this one over here don't make a diameter. These ones over here, they're all 3, okay? But the only one that makes a diameter with this radius right here, in green, the only one that makes a diameter is the one that keeps it going at a 180-degree angle, okay? So you have to know that the diameter right here makes this angle right here, that is 180 degrees, okay? So, the next thing we need to attack this problem, which is actually a very deep problem and complicated problem of history. I could just give you a formula, but the definition of pi is what I'm going to give you instead. Because I know you guys want this to make sense. And if I'm going to go through the trouble of making a video, it's going to make sense. So, here we go. The definition of pi since the beginning of time has always been what's the ratio of any circle in the world to the diameter. So what's the ratio of the width of the circle, if you think of the width as being the diameter, and what's the ratio of the circumference, the area around the circle, to the diameter. The circles are very deep shape, but it's not obvious at all that this is always going to be the same number. And the truth is that over years and years of troubling over this, it really keeps going on and on forever, okay? But we're going to stop right there with 3.141. Let's fix that 5. We have respect for pi here, okay? 3.1415 is pi. The circumference of the diameter of any circle, even if I draw a little one or a big circle. If I take the diameter of the circle and the circumference of the circle, and if I divide that by the diameter, I should always get 3.1415 ... It goes on forever. If that circle is perfectly round, unlike this circle that I drew, right? The circumference of the diameter is always the same thing, and that's kind of remarkable in a way. We're lucky that circles aren't more complicated than that because they're really useful. So if I want to find the circumference of the diameter, hey, this word's kind of long, huh? Why don't we abbreviate circumference with C? And why don't we label diameter with D? Okay, maybe I'll move this all over a little bit. Okay, so don't forget that 3.1415 is pi. But pi equals the circumference over the diameter. So if I want to find the circumference, I have to multiply both sides by the diameter. So I get the diameter on this side. I multiply both sides by the diameter. Well, those cancel out on this side. And I get the diameter times pi equals C. And usually, we like to think of the diameter as being, there's one radius and there's another radius. So how long is it? It's as long as 2 radius. So I can abbreviate the diameter with 2r. It's just double the length of the radius. So if this is 3, then the diameter is 2 times 3, right? It's 3 plus 3 is 6. So, our circumference formula is twice the radius times pi. And that's exactly what we're going to do to find this circumference right here. So, now using our formula, 2r pi, which some people like to write 2 pi r, but we're going to use 2r pi because it's a little more fluid when you do calculations. So all you have to do is plug in the radius here. And the radius in this case is 3. So we're going to put 3 in here. And then we're going to get 2 times 3 is 6. And we're going to put a pi. And we're measuring in centimeters. So we have 6 pi centimeters. We can go ahead and plug in the first few digits, 3.14 times pi centimeters, to find out exactly how much our circumference is. So here we go. I'm going to my calculator. And I'm going to do 6. I hope you guys are doing the same. Go to your calculator too. Do 6 times 3.14. And I got 18.84. So that little step kind of broke up the flow of our problem. Did you see that? I had to reach to get my calculator to actually calculate how many centimeters it is. But circumference is the distance around the circle. If I was going to put like a string around this circle, it would have to be 18.84 centimeters long to go all the way around the circle, okay? So let's practice on another problem where we're going to learn how to do it. Except this time, I'm just going to stop here so that you guys can get the hang of this without having to do too many calculations. And you guys can do this step on your own and just realize that since pi is always the same, you're going to put in 3.14 and go ahead and multiply that in your calculator, okay? So, circumference equals 2r pi, and we're going to put in our radius. And what's the radius in this case? Our radius is right here. Our r is 10. So I put 10 in here. 2 times 10 is 20. So 20 pi. And we're measuring in inches, so go ahead and leave that. Make sure you put that in there at the end. Okay, so is our final answer. The circumference of this circle, if I wanted to have something to go around the circle, it would have to be 20 pi inches long, okay? Let's go. So here we go. So this is our circumference formula we're going to use every time. Make sure you read the problem. It says we're finding the circumference. If it says area, don't use this formula. So, the radius is 6. So go ahead and pop 6 in your equation, and we get 2 times 6 is 12. And go ahead and leave your answer as 12 pi kilometers. Okay, you guys can do the multiplication on your own if you feel like it. So let's see you do one. All right, go ahead, pause the video and try it right now, and we'll see if you know what to do. And if you get stuck, you can keep the video going, but don't just feed yourself the answer. See how much you can do once I just give you the formula, okay? So go ahead, practice. And here we go. So did you write 2r pi, the circumference formula? If you didn't write this down yet, you might want to take a note of it, okay? It's definitely an important formula you'll need in any geometry class, especially mine. So, what do we put in for our radius? In this case, our radius is 9. So just put 9 in here. 2 times 9 is 18 pi. So this is, oh, and don't forget the miles. Alright, so this is about 18 pi miles around. Okay? So now we have a totally new formula. Okay, we have the area of a circle. Okay, in this case, to find the area, what is area? What does area mean? Okay, let's go back a little bit. Let's think about this. The area of a square, okay, if it's 1 by 1, we say it has an area of 1. Say this is 1 inch, and this is 1 inch, all right? We say this is 1 square inch, okay? You might even say 1 inches squared. So, say I put 1 foot, okay? And this is also 1 foot. Then we would say this is 1 square foot. I'm not sure if you ever heard the term square foot, but that's exactly what we're measuring here, okay? This foot looks kind of funny, right? So, the idea is, let's just scrap all of this, okay? Say we had a square that was 3 by 3. I'm pretty sure everybody's seen a tic-tac-toe grid before, knows there's 9 boxes. So the area in this case is, if this was 3 feet and this was 3 feet, we would say we have 3 times 3, right? Square feet. And what's 3 times 3? 9. So we say we have 9 feet squared. All right, 9 square feet. And that's what we're measuring. In this case, we put a little square up here to note that. Now look what we're measuring. We're not measuring a one-dimensional string. All right, I can't cover the floor with a string. This is like measuring a tile. This is measuring a two-dimensional space. So to show that, we put a little 2 up here to give us that sense that we're measuring in 2 dimensions, okay? The same thing happens when you're measuring in 3 dimensions, but that'll be another day, okay? So, this is an interesting problem. And I'm not going to go into how you get the formula for this. It would probably take some calculus or some really complicated diagrams at any rate. But what I'm going to try to show you is, I'm going to try to eyeball it, all right? It would be about 3, 4, 5, 6. It's talking about how many squares would fit in this. And I'm trying to use a step length of 1. It's coming out kind of okay. So, how many squares are there in this diagram? Okay, well, yeah, we could go down on our hands and knees and we could count them, couldn't we? But look at these little spaces right here. Look at these little gaps. How much of a square is this little thing? Who wants to measure those things, okay? It turns out that there's a nice and neat formula for finding out how many squares there are here, okay? And if there's not a whole square left, how many little, like, percentage of a square? Do we have, like, 0.2 of a square? You know, do we have half a square? Do we have 0.8 of a square? This is the way to do it, is you just put in this formula right here. So, the only thing we need to use for our formula is the radius, just like the last formula. And the radius in this case is 6 meters. So I'll put a 6 in here, and we get 6 squared is 36, and we usually write it 36 pi. The other way around, we usually put the numbers in front of pi. So, 36 pi meters. Okay, well, what does that mean? We were talking about how many squares there are. So for this time, I'll actually plug in the number 3.14. Okay, so here we go. .36 times 3.14, and we get 113.04 meters squared. So that tells me that if we really wanted to count them, if we had to, we would find that there's 113 of those squares there. Okay, I don't know if you want to do that or if you'd rather multiply a number. Okay, but that's how you figure out how much space a square takes up, how much two-dimensional space, how much two-dimensional area a square takes up. Okay, you just plug the radius into this formula and you get the calculation. Okay, so we're going to symbolize area, of course, with the A, and that's how we're going to do these problems, so stay with me. We'll do some more examples. So, we're going to use our area formula, is pi r squared. Sorry about that kind of dilapidated r. So, in this case, r is 5. So this is my radius, so we plug in 5 just like we did in the last problem, except now, try to remember that 5 squared doesn't mean 5 times 2. It doesn't mean 10. It means 5 times 5. So, just so I can go ahead and show this for clarity, that's pi times 5 times 5. And 5 times 5 is 25. So we're going to write this as 25 pi. That's just the way that we like to write it. Okay, so maybe now you'll see what I was doing with the last equation. Maybe you want to write your equation the other way around so it doesn't have to flip around, right? Maybe you want to write r squared times pi. That would be also good, because since we're just multiplying them, it doesn't matter. It doesn't make a difference. So first put in your radius. And what's our radius in this case? Oh, just look at it, right? The radius is 8. So I'm going to put 8 in here. And 8 squared is 8 times 8. And we get 8 times 8 is 64. 64 pi. Alright, and that's the answer in this case. If you disregard what it's saying right here, don't worry about rounding to the nearest tenth. That's not what I'm going to do. If you wanted to, you would just multiply 64 times 3.14. Okay, and don't forget we're measuring in meters either. Alright, so you could do that on your own if you want to try to figure out how many squares there would be in this one. Okay, you could try to count them if you really wanted. So let's do another one. Okay, the area of this okay, so either you write it pi r squared or r squared pi. It doesn't matter. We're going to get the same thing either way, okay? It's up to you. Usually textbooks have it written this way, so you might be confused if you see this and you could be like, whoa, wait, what's the difference? Is there a difference? I don't know. Pi. Pi is just a number, and if you multiply two numbers, it doesn't matter. 3 times 2, 2 times 3, you get the same thing. So it's up to you which way you want to write it. I'm really, really used to writing it this way, so that's why it keeps coming out that way, even though I feel like I should probably show you guys to write it this way, just so you don't get confused, right? So, go ahead, try to find the answer right here. Pause it, find it by yourself. And I hope you got 10 squared times pi. 10 squared is 10 times 10, so we get 100 pi. Alright, that's the area of this circle. So, let's see, did I give another one? Yeah, so check out for my next video, okay, arc length, okay? Check out, okay? Check out the ACME Red Devils, okay? Click ACME Red Devils, go to the channel, and look for the next video I'm going to do on arc length, okay? Because you might be studying the same thing. Hey, check it out. See you guys later.